And one of the ones we're going to look at is probability trees. I'm going to look generally at probability, but focus on probability trees for maths. And what I'm going to go through is work out what we mean by combined probability, and then use probability trees for both what's called independent and dependent questions. But that will make sense when I get to those. You'll understand what those mean. What we have done on some of the other sessions, particularly the math sessions, I've done that and then given people time to work through an example. It take a little bit of a while to work through the combined probability questions and probability trees. So instead of, we'll work through some examples on screen. I will give you time to work out them as I go along, but you might find it more useful to do it afterwards. So after the session, everybody who's attended, my colleague Sophie's going to email you all some questions on combined probability for you to have a go at in your own time, and you can send it then back to your own tutor. You're welcome to send it back to me or Sophie and she'll forward it on, but if you want to send it to Sam or Asia or Eamon, whoever your own tutor is, they'll mark them as well. So we'll do a bit of follow-up rather than giving you much time in this session to work out. Pen and paper would be very useful. May not need a calculator for this session, I don't think, or not as much, but if you have got one, that's good as well, but pen and paper particularly. So thinking about probability generally, we've asked these in all of our sessions so far. In the little chat window, can you score yourself from 1 being the lowest, 10 being the highest, how confident you feel about working out probability and what that means? If you've never heard of probability, go for 1 or 0, I suppose. If you feel quite confident, then go up towards 10. How feel you generally with probability? Some scores coming in. Some lower scores, which is not uncommon. It is, I think, probably up there with probably the hardest topic in functional skills maths, certainly one of them. But that's what I'm here for, to try and break it down for you. So that's probability, some low scores. I'm guessing I'll get the similar answers there. How about for what this thing called combined probability? I suppose if your score's low for probability, it probably is as low for combined probability. But anybody heard of combined probability and say, yeah, I know that bit, I'm 10 out of 10 for that one. We've got a 0, so, so that's a definite. That clearly tells you what you think, and a number of 1s as well. So that's very useful. As we've said with these sessions, they're only bite-sized sessions, so I can't guarantee I'm going to solve everything and get you all to 10 by the end of it. But hopefully, it'll give you some ideas to go forward with. And there's obviously always further learning and further support you can get. So I will start just generally on probability, because a few people have got lower scores of that. So probability is basically the likelihood or the chance of an event occurring, something occurring. So what's the chance that, if whatever the scenario, of that thing occurring that they're asking you to do? And the easiest way to work out probability is that you look at the number of ways something can happen and you divide it by the total number of possibilities. I'll give you an example in a moment that will hopefully explain that and work through it for you. I'm just looking at the chat, so I saw another message there. Great. Let's just begin. With probability, there's 3 ways of reporting probability, of giving you answer, either as a fraction, a decimal, or percentage, and all of them correct. Something can have 1 in 2 chance, 1 over 2, which is the same as decimal as 0.5, or as a percentage, that would be 50%. Unless the question specifically says it wants a fraction, a decimal, or percentage, any of those is fine. We usually work with fractions and percentages more than decimals, although not necessarily. And obviously fractions are out of 1, so 4 out of 4 is the same as 1, or 10 out of 10 is the same as 1. Decimals is also 0 point whatever up to 1, and percentage is obviously always out of 100. Today I'm going to mostly use fractions. If you want to, when I've done the answers, if you wanted to change them to decimals or percentages, you could do. And if you're not sure how to do that, then we can cover that in a separate session, or again, there's sessions out there that can help you with fractions, decimals, and percentage. But I'll mainly work in fractions, but I will give a couple of examples. So in terms of probability, I've said that the way you work it out is the number of ways something can happen divided by the total number of possibilities. So a favourite always with probability is looking at dice, and we all know a dice goes from 1 to 6, 6 sides to a dice, and there's numbers 1, 2, 3, 4, 5, 6 on each side. And so a question might be, what's the chance of throwing a 6? Well, if we use that example there, I said the number of ways something can happen. Well, there's only one way I can throw a 6 because there's only 1 6 on the dice. But my total possibilities is the 6 of them, because I could get 1, 2, 3, 4, 5, 6. So as a fraction, it's 1 over 6. I haven't written there very prettily there, have I? 1 over 6. So then my chance of throwing a 6 is 1 over 6, or 1 chance of it happening out of 6 possible opportunities. I can turn that into a decimal by doing 1 divided by 6, which gives me 0.167. And then I can multiply that by 100 to give me a percentage. So the chance of throwing a 6 is any of those, 1 over 6, 0.167, or 16.7%. Another question I could look at is, what's the chance of throwing an even number? Well, on a dice, there's 2, there's 4, and there's 6. So there are 3 even numbers. And obviously out of the total number of 6, there's still 6 numbers on a dice. So throwing an even number is 3 over 6. And again, if you've done any fractions work, you'll know that that can be simplified to the same as a half. And also, once again, if I erase that, I can show you that 3 over 6 is the same as a half, and that is the same as 0.5 or 50%. And again, any of those would be fine, but I'll tend to use fractions more so. So probability in simplest terms is the number of ways something can happen divided by the total number of possibilities. So I mentioned this thing called combined probability. And this is basically the chance of more than one thing happening. So we rolled a dice and I said, what number do we get? 1, 2, 3, 4, 5, 6, or even numbers or odd numbers, or more than a 3 or less than 2, whatever it might be. But a combined probability is 2 things happening. So it may be we roll a dice more than once. So let's do exactly that. So let's say we roll a dice and we get 6. And then what's the chance of rolling it again and getting another 6? So we said before, the chance of, let's take this first example, a first option of throwing a 6. Well, the chance of throwing a 6, who said is 1 over 6. And then we roll the dice again, and what's the chance of getting another 6? Well, again, it's 1 over 6, because the dice hasn't changed. So both of those opportunities, both of those situations have a probability of 1 over 6. And when we're doing a combined probability, what we do to work out the combined is we multiply them together. And again, bit of fractions work here. When you multiply in fractions, what you do is you multiply the top line, and you multiply the bottom line. So 1 times 1 is 1. And 6 times 6 is 36. And that's our combined probability. So the chance of throwing a 6 and then throwing another 6 is actually 1 over 6 over times 1 over 6, which gives us an answer of 1 over 36. And we turn that into a decimal, 0.028, or multiply it by 100 to give us a percentage of 2.8%. So if I just erase all that and look at the next option. So what's the chance of throwing 2 even numbers? Well, we said there's 2, 4, and 6 on a dice. So the chance of throwing an even number is 3. And that's out of a total number of 6. And then we throw the dice again. And once again, we've got a chance of 3 over 6 for an even number. And as I said, for combined probability, what we do is we multiply those together. One thing I would say at that point, you may be looking to say 3 over 6 is the same as a half. So I could simplify that to a half. What I strongly recommend when you're working with fractions is don't simplify it yet. Keep it as it is, and we'll look at simplifying at the end. So 3 times 3 is 9, and 6 times 6 is 36. And at this stage, we know that 9 goes into 36 3 times, so that's actually the same as a third. Sorry, my fault, 4 times. Right, easier if I do my correct maths, wouldn't it? So 9 goes into 36 4 times. So it's the same as a quarter. So the chance of getting 2 even numbers is a quarter, which is also known as 0.25 or known as 50%. So again, all we've done is the chance of something happening divided by how many possibilities are there. And then for combined, we've multiplied the 2 numbers together. When you do a combined probability such as that, you can just think, well, I know that the 2 chances are 1 over 6 and 1 over 6, so I'm going to times them together, and that's absolutely fine for you to work out. And again, you could do that with decimals or percentage. However, there's slightly more complicated examples, and these are when things are can either be independent or dependent. And as I say, I'll explain this when we go on. So an independent probability is the chance of one thing happening, of more than one thing happening, sorry, where the outcomes do not affect each other. I'll give you an example, and hopefully that makes sense. So if you imagine I've got a coin and all I could afford was a 20p, but I toss the coin and I want to know what's the chance. I'm going to toss it once and then I'm going to toss it again. I'm going to look at whether I get head or a tail. I toss the coin, I get head or tail, and then I toss it again. And the second time the first one has no impact on the second time. So it doesn't matter what I got first time, second time I will still only get head or a tail. It doesn't affect each other. Obviously the outcomes, as I said here, do not affect each other, because whatever I get first time has no effect on the second toss. I'm still got a head or a tail. So let's have a look at, we're tossing it twice, and what's the chance of getting a head at least once? And for this, it's a little bit more complicated. We're going to draw this tree diagram. And this is why I said, this is obviously pre-drawn for me to show on the screen, but you would need to draw this yourself, and you do one line at a time, which is why I'll ask you to do this afterwards. So we toss a coin, and we can either get heads, or we can get tails. And we write them in there, and this is our first throw here, first toss of the coin, and we're either going to hit heads or tails. What you would normally do with a tree diagram is write the probability of that happening just here, where I'm going to write it on the left-hand side here. So can anybody tell me, and it's not a trick question, what's the chance of getting a head when you toss a coin? Just tell me in the chat, what's the chance of tossing a coin and it being a head? And yes, 1/2. Yeah, lots of 1/2s coming in, 50%, great. I could put 50% in here, but I am going to keep it as a fraction, just because I find them a little bit easier to work with, and you'll see why in a little bit while. It can get a little bit complicated with percentages and decimals, so let's keep it as a fraction. And obviously, there's a half a chance of getting a head and half a chance of getting a tail. We'll assume, ignore the fact that it could land bang on in the 1 in a million chance it lands on end up. We'll assume you're either going to get a head or a tail. So that's our first toss of the coin. We're then going to toss it again. So this top bit, we've got a head so far, and we're going to toss it again, and we can either get a head or a tail. And as I said, whatever we got first time has no impact on the probability second time. So the probability this time is a half still. And if we go to the bottom, we got a tail first time. We toss it again, and we might get a head, or we might get a tail. And once again, the chance of both of them is 50% or half for each of them. If we now follow down our tree diagram, this top outcome is that we get head and then a head. And to work this out, I said before that what you do if you've got combined probability, you simply multiply them together. So the probability of the first head is a half, and we multiply it by the probability of the second being a head, which is also a half. Oops, that's meant to be an equals, and that will give us an outcome of a quarter. This second probability here is heads and then tails. And actually, if we look, that's a half and a half, so that's a quarter as well. We're noticing a pattern here. Down here, we get a tail and then a head. And that is obviously going to be the same outcome as well. And then finally, we got a tail and then a tail. And so the outcome of that is a quarter. So actually, each of our outcomes, we've got 4 outcomes, and they've all got an equal chance of coming out because they're all a quarter. One thing you might notice now, which isn't hard to spot, is if we added all these things together, ooh, that's not a very straight line, but that's as good as I'm going to get. If we add all this together, it comes to 4 out of 4, which is obviously definitely going to happen. It's a 1. And obviously, of course, it is, because those are the 4 outcomes, and obviously combine them all together, that has got to happen, one of those. So we can look at those to know that we're definitely on the right track. Let's go back to the pen. The question was, what's the chance of getting a head at least once? I'll give you a second before I write it on. You don't necessarily have to put it in the chat, although you're welcome to. Have a look at those 4 options at the end. Which of those would you say is the chance of getting a head at least once? And the key is at least once, not exactly once. And hopefully you're already spotting, well, this one does, because this actually gets me 2 heads, which is great. So that's at least 1 because it's 2. This one gets me a head. This one gets me a head. And this one doesn't because this was 2 tails. We'll ignore this one. So my probability of getting at least 1 head is this one, and this one, and this one. And because we want all 3 of them, we're going to add them together. And again, if you're not aware of adding fractions, that's something we can cover separately. But when we add fractions, they're all over 4. So we've got 1, add 1, add 1. So 1 and 1 and 1 is 3. And we just keep the bottom, what's known as the denominator, as 4. And so the chance of us getting a head at least once is 3 out of 4, 3 quarters, and we can change that to 0.75 or 75%. So the key here, going down the tree diagram, is I multiply, as I go down the diagram or along the diagram here, I multiply them together. No matter which route I go, I have to multiply the outcomes together. And when I've got my outcomes at the end, I choose how many I want and I add them together. So I'm multiplying and I'm adding fractions to 2 things. And I can see a few people in the chat have got 3 out of 4, which is brilliant. So that's known as an independent probability tree, because whatever we did in the first outcome has no impact whatsoever on the second outcome. That's quite common. That's good. And actually, if the question was just what's the chance of getting a tail then a tail, you may not bother drawing a tree diagram because you know it's a half and then it's half and you just times them together. The benefit of doing that and the tree diagram just means if you want more than one thing to recognize that you want head, tail, tail, head, and head, head. Probably more complicated, I would argue, is a dependent probability tree or probability. So this is the chance of more than one thing happening where the outcomes do affect each other. Now let's give you a scenario. We have a bag of red and blue balls, not as many in the picture there. And in the bag, there are 3 red balls and 2 blue balls. If you can imagine this bag, imagine in front of me, and I'm going to pick a ball at random. I'm going to know it's either red or blue, and then I'm going to get rid of that ball. I'm then going to pick another ball at random, and I'm going to get rid of that. And I could do that 20 times if I want to. I'm just going to do it twice. And the question is, what's the chance of picking a red ball and a blue ball? Now, obviously, when I pick the first ball out of the bag, that changes the number of balls in the bag, both red and blue balls, and the total number of balls. So that's why this is dependent, because what I do first time impacts on what I'm going to do second time. And again, if I work through a tree diagram, hopefully that will make sense. So we're going to look at a tree diagram this time. There's my balls. And I'm going to try and change the colours a little bit. Now, I know using red and blue isn't great for everybody, but hopefully you'll distinguish between it. So here's my first pick, and I'm going to put my hand in the bag, and I'm either going to pick out a blue ball, or I'm going to pick out a red ball. Can anybody tell me, and the scenarios at the bottom again, what is the chance of me picking out a blue ball at this stage? So this is my first, put my hand into the bag, and I pick a ball out. What is the probability, the chance of that being a blue ball? My answer's coming through. Remember, the probability is the chance of something happening over or divided by the total number of opportunities. So the chance of me getting a blue ball, well, there's 2 blue balls, it says at the bottom. So the chance of me getting a blue ball is 2. And there are 5 balls in total. So it's 2 out of 5. So well done, anybody who said that. If I think about the red, there are 3 red balls. So the chance of me picking out red, remember this is my first delve into the bag, is 3 red balls out of a total possibility of 5. Let me try and be visual over here. And that's meant to be a bag. That's probably the best circle I've ever done on this. But it's almost a bag anyway. And let's say that we've got, remember in the bag, there are 3 red balls. And there were 2 blue balls. And that is meant to be a bag of balls. It's not some creepy looking snowman. It really is a bag of balls. And let's go back to our pen. So let's take the second pick now. So the first pick, I'm going to look at this part of the tree diagram up here. So my first pick, I chose a blue ball. And my second pick, I could then choose another blue ball. Or I could choose a red ball. Now let's look at this diagram. Probably diagram's probably a strong word for this strange thing that I've drawn on the right. But that was our bag originally. And we've said we first of all chose a blue ball. So let's take a blue ball out. So the question now is, what have we got in our second pick? What is the chance of us picking a blue ball? Well, hopefully there you can see there's only 1 blue ball left. So it's 1. And there are 4 balls in total. So we've now got a 1 in 4 or a quarter chance of picking a blue ball. You can also see in that bag there are 3 red balls. So my chance of picking a red is 3 out of 4. Let me put my blue ball back in. And then if we think about the bottom line of our tree diagram, I took out a red ball. And so can anybody tell me, if I've picked out a red ball first, what's now the chance of me picking out a blue ball? I'll write this in, if you can put the answer in the chat. A bit clunky with the colours, but hopefully you can see them okay. Great, and answers coming through and correct. There are 4 balls and 2 of them are blue. So it's 2 out of 4. And red balls, there's still 2. And that's out of 4 as well. So actually they're the same there. At this stage, again, 2 out of 4 is the same as a half. So you could simplify that to a half. I personally don't. I tend to think, well, I'll leave it till the end, because rather than simplifying it now, doing another calculation after simplifying again, why don't I just leave it and do it once? It'd be much easier for me and give me less work to do, which is always a good policy. So at the top of our tree diagram here, if we went along this tree diagram, we would have a blue and then a blue, and then a blue, and then a red, and then a red, blue, and red, red. Let's start at the bottom this time. Can anybody tell me what is the chance of me getting a red ball and then a red ball? So I'm talking at the bottom of the tree diagram now. I've gone for the bottom. What's the chance, and put it into the chat as a fraction if you can, what is the probability, the chance of me getting a red ball and then another red ball? So remember, when I'm going down the tree diagram, I need to multiply. Some answers coming through. I've got 3 over 5 as my first red ball. Oops, 3 over 5. And I'm going to multiply that by the chance of my second red ball, which is 2/4. And I mentioned before that if you multiply fractions, you multiply the top line. So 3 times 2 is 6. And you multiply the bottom line. 5 times 4 is 20. So 6/20. I could simplify that down, but as I've said before, I'm not going to at the moment. I'm going to leave that to an end. I think some people have simplified down, which is absolutely fine, but I'm going to leave that 6/20. If I notice now, if you look now, red then blue is actually the same. It's 3/5 and then 2/4. So actually this is going to be 6/20 as well. This one is a bit different, but I'm going to get the same answer. So this one is 2/5 times 3/4. Same numbers, just a slightly different order. So that's going to give me 6/20 as well. And then the final one we've got up here is blue then blue. Well, it was 2/5 and then 1/4, 1/4. And if I multiply these together, 2 times 1 is 2 and 5/4 is 20. And so one of the benefits of me not simplifying is you'll see all of these at the end now all end in 20, which is good because when I'm coming to add them together in a moment, that'll be really useful. And if we look, if we do 2, add 6 is 8, add 6 is 14, add 6 is 20. So we know we've got the right numbers because out of all of those, they come to a total of 20 out of 20, which is what we want them to. And then if we go back to our question, the question at the bottom was, what's the chance of picking 1 red and 1 blue ball? As I hope you'll agree, this picks a blue, oops, not if I go off it won't. Yeah, there we go. Right, so this option picks me a blue and a red ball, and so does this. So my two probabilities, and I'll have to go to the top left here because I can't write it on there. My probabilities of blue then red is 6/20. My probability of red then blue is 6/20. And because I want both of them, I add them together. And 6 add 6 is 12. And it's out of 20, so we'll leave it out of 20. I could simplify those both down, and if I halve them, they'd become 6 out of 10. And if I halve them again, they'll become 3 out of 5. I can't simplify any further than 3 out of 5. So our answer for what's the chance of 1 red ball and 1 blue ball is 3/5. So as I say, that's a dependent tree diagram. They've got some pretty pictures there. It would have taken me even longer to try and draw those in, but hopefully the kind of diagram I did explain that a little bit. So as I said, I appreciate they are difficult. They are probably one of the most difficult things in functional skills maths. And obviously this is we're only doing 2 picks. We did 1 pick and then a second. You could have 3, 4, 5, 6 picks. It wouldn't go that lengthy in your test, but it could have 2 or 3 levels. If you can work them out, a bit like we did with the dice or the coin, then you don't need to draw a probability tree. But I would say, particularly if they're dependent, such as this one, you'll probably find a probability tree is really useful. But just go back, if the question had been what's the chance of getting blue and blue, what I could have done is I could have drawn my probability tree. Let me do this. And I could have ignored all of this here. I could have just drawn that top line of my probability tree and it would have been absolutely fine because that's all I needed. As it happened, we wanted more information there. So you may not need to draw the full probability tree. You might only need to draw the bits that you need, but it depends on the question. So I appreciate a lot there, but hopefully you understood now what we mean by combined probability, and that's a chance of more than one thing happening. You've then got the use of probability trees for either independent questions where one thing doesn't affect the other, or dependent questions where one thing does affect the other, like I've said at the end there, where you take a ball out and remove it, and then obviously that has an impact on the next question. Ideally, if we had more time, I would now practice a full question with you. But as I said, because these are bite-sized, we did want to try and keep them to a shorter amount of time. So Sophie, after this, will email you all with some questions to practice. You might find it good to draw a probability tree. You might think you don't need to. I would suggest as good practice, have a go at drawing one, because even if you think you know the answer, have a go at drawing one and see what you come back with. Send your questions, your answers back to your tutor and we'll mark them. And if you're unsure about anything, again, as always, there's support on Skills Forward for you. We can provide support and there's lots and lots of resources out there that can help you with probability and probability trees. So a lot to take in a short session, but can you have a think now how you feel about, particularly about combined probability, and maybe put your score on there for me. Libby's put a great one there, which is really good. Better understanding, but we'll definitely need to practice. I I agree. If anybody says, yeah, I know it all, that's fine. I would argue they'd need some practice. So I think certainly with this one, it is definitely something that needs practice. Hopefully, as I went through it, if it made sense, I went through it. Hopefully, you appreciate it. It's not actually that difficult once you know where you are on it. But the more practice you get, the better. And there's a lot of opportunities out there. And again, myself or any of the other tutors will be happy to go over it again. As always, I'll stay on the call for a little while now. If you have got any questions, if you want to put your microphone on, ask direct questions, or if you want to put anything in the chat, Sophie will send out those questions to you at some point in the future as well. So please do just let us know if we can help you in any way. And once again, thanks for listening.